All right, let's dive into something pretty cool today. We're going to be looking at the world of biopharma, specifically a new pump that's generating a lot of buzz called the PIXER. And we've got some interesting stuff to dig into, excerpts from a scientific study, a product overview that's got all the technical details, and of course, one of those glossy promotional flyers that companies love. So our mission, if we choose to accept it, is to figure out what makes this PIXER pump so special, how it actually works, and why everyone in biopharma seems to be talking about it.
Well, what's really interesting here is that it's not just another pump. The Pixar is being presented as a sort of all-in-one tool for biopharma, mixing, diluting, moving fluids, and it does all this with incredible care, which is really important when you're often dealing with, very sensitive and expensive substances.
Right, it's like the difference between pouring a fine wine and shaking up a soda, right? You want to treat those delicate molecules with respect. Speaking of care, let's talk about that scientific study you shared. The one that really dives into the Pixar's mixing efficiency, that's got to be crucial in biopharma.
Absolutely, yeah. I mean, imagine you're working on a life-saving medication. You wouldn't just throw the ingredients together, right? Thorough and consistent mixing is critical to ensure that every dose is formulated correctly. And that's what this study aimed to assess, the Pixar's ability to mix properly.
Okay, so they put it through its paces. What did they find?
They tested it with sodium chloride and sodium hydroxide solutions, fairly common in biopharma settings. And simulating real-world conditions, they varied the concentrations, the flow rates, pressures, really put it through a range of scenarios.
Did it pass the test?
Oh, with flying colors. The study concluded that the Pixar's mixing was so good that you don't need any additional mixing steps before using the output.
Yeah.
I mean, think about it. That's potentially a 15% reduction in cost, maybe even saving several hours per batch. That's huge in large-scale biopharma where efficiency is everything.
Wow, eliminating a whole step in the process. That's impressive. But what's the secret? How does it achieve this level of mixing?
Well, it's not magic, but it is ingenious engineering. One key factor is the Pixar's unusual vertical orientation. It stands upright. And this seemingly simple design choice makes a big difference.
So why is the vertical orientation such a game changer?
Two main reasons, actually. Firstly, having the inlet at the top utilizes gravity to help prime the pump, which means you can get it up and running faster. And secondly, this setup helps prevent air from getting trapped inside, which, let me tell you, is a major concern when you're dealing with these sensitive materials.
Yeah, air bubbles in a sensitive biopharmaceutical solution. That's like finding a hair in your soup, not a good sign.
Exactly. Air bubbles can really mess things up, potentially impacting the quality and stability of the final product. But the Pixar's design minimizes that risk significantly.
Gotcha. So vertical orientation, check. What else contributes to this impressive mixing?
Well, the heart of the Pixar is its diaphragm system. It uses 5 diaphragms in a tight radial arrangement, kind of like a star-shaped heart. And these diaphragms gently push the fluids through the pump, resulting in this really smooth, low pulsation flow. It's more like a gentle stream than a pounding waterfall.
Gentle and consistent. Perfect for those delicate cells and proteins that need a smooth ride.
Exactly. And that brings us to another major advantage: low shear. Basically, shear refers to the forces that can damage these delicate molecules as they're being moved around. And the Pixar's design minimizes these forces, protecting those valuable materials every step of the way.
So it's like a bodyguard for these sensitive biopharmaceuticals, making sure they get through the manufacturing process unharmed.
That's a great analogy. And because the Pixar is designed to be completely drained, product loss is minimal, which, again, is crucial for maximizing efficiency and reducing waste, especially with high-value substances. Every drop counts.
Okay, high efficiency, protection of valuable materials, the PIXER is shaping up to be quite the biopharma hero. But we've only scratched the surface here. This product overview mentions something called polymorphic pump technology, which honestly sounds like something straight out of Star Trek.
It's definitely one of the most interesting aspects of the Pixar, and it's where this technology really sets itself apart. But we'll delve into that more in the next part of our deep dive.
You've piqued my curiosity.
Hey.
Can't wait to uncover the mysteries of this polymorphic pump technology.
So last time we were about to unlock the secrets of this polymorphic pump technology.
Yeah, it sounds pretty futuristic, doesn't it? It does. So, what is it exactly? What makes it so special?
Well, imagine a pump that's not stuck in one configuration, one that can be customized for different tasks, different workflows. That's what this technology is all about.
Okay, that sounds pretty impressive, but I need a little more than that. Can you give me an example? How does this customization work in real life?
Sure. Let's say you're working on, say, a cell therapy project. And you need to very precisely blend multiple components to make the perfect cell culture media. With the PIXER, you're not limited to just one input. You can have multiple inlets, each delivering a different component to the pump.
So instead of having a bunch of different pumps for each thing, you can do it all with one PIXER.
Exactly. It streamlines the whole workflow. And it's not just about multiple inlets either. Imagine you've grown your cells and you need to transfer them to different containers for storage or for the next steps in the process, downstream processing. Well, the PIXER can handle that too, thanks to its multiple outlet options.
So it's like a Swiss Army knife of pumps, adaptable to all sorts of tasks. That's got to be a big deal in biopharma where equipment can be so expensive and specialized.
Yeah, absolutely. This kind of adaptability has the potential to really shake things up, offering a solution that's both cost-effective and super flexible.
Speaking of applications, where does this pump really shine in biopharma?
That's the exciting thing. It's got the potential to impact every stage of biopharmaceutical manufacturing, starting with, upstream processing where cells are grown in those big bioreactors.
Ah, the bioreactor's the heart of biopharma, right?
Exactly. And because the PIXER is so gentle, it's perfect for these sensitive environments.
Right. We were talking about those shear forces that can damage delicate cells.
Exactly. The PIXER minimizes that risk, creates a much better environment for cell growth and viability.
Happy cells, happy scientists. Now, what about midstream processing? Where does the PIXER fit in there?
So midstream is all about purification, preparation. You're basically separating those valuable proteins from the cell culture and getting them ready for final formulation. This stage involves lots of mixing, diluting, transferring fluids, perfect for the PIXER.
It does sound like the PIXER's precision and on-demand capabilities would be right at home in that stage.
Yeah, absolutely. Let's say you're working with, say, a phosphate-buffered saline solution. It's a very common buffer used in labs. The PIXER can ensure that your buffer preparation is accurate and consistent every single time.
Efficiency, accuracy, consistency, the PIXER's hitting all the right notes. Okay, let's move on to downstream processing, the final act of the process. What challenges does the PIXER address at this crucial stage?
So downstream is all about final purification, polishing things up. You're making sure the product meets those incredibly high standards required for patient use. It's a critical stage where even the smallest mistake can be a huge problem.
High stakes indeed. So where does our friend the PIXER come in?
Well, take tangential flow filtration, or TFF for short. It's a common method for concentrating and purifying biopharmaceuticals. And the PIXER, with its low shear, high flow rates, and precise control, is ideal for this process.
So from the very beginning, with cell growth, to that final purification, the PIXER is proving itself as a versatile tool in the biopharma world.
That's a great way to put it. But it's not just the pump itself that's exciting. What's really interesting is that the company behind the PIXER is thinking bigger, creating a whole ecosystem to really maximize its potential.
Now that's thinking ahead. It's like they're not just selling a product, but a whole new approach to biopharma manufacturing. Tell me more. Tell me more. What's in this ecosystem?
We'll dive into all those exciting details in the last part of our deep dive.
All right, so we're back, ready to wrap up our deep dive into the world of the PIXER pump. And last time, we were about to explore this ecosystem they're building around this tech. Not every day you find a pump with its own ecosystem, right?
It's pretty impressive, right? They're not just selling you a piece of equipment. They're offering a whole solution for biopharma manufacturing.
Okay, I'm intrigued. So what does this ecosystem actually look like? What are the key pieces they're developing alongside the pump itself?
Well, one of the core elements is this really sophisticated software platform. It's called Procasso, and it's specifically designed to control and monitor the PIXER. And it's all cloud-based, so you've got real-time data insights and remote accessibility.
Cloud-based systems are becoming so essential these days. Having that data at your fingertips, being able to adjust things and keep an eye on performance from anywhere, that's a game changer, especially in a field like this.
Absolutely. Procasso really gives you that level of control and oversight you need in biopharma, especially with these really sensitive processes and all the regulatory hoops you have to jump through. But it doesn't stop there. They've also built in predictive maintenance capabilities.
Predictive maintenance. Hold on, are we talking about a pump that can tell the future now?
Well, not quite. But through a whole network of sensors and some really clever data analysis, the system can actually anticipate potential problems before they even happen. Imagine getting an alert that a part is wearing down and needs replacing before it even becomes an issue.
That's incredible. Think about how much time and money that could save biopharma companies. Not to mention potentially preventing delays in production.
Exactly. Downtime in this industry can be incredibly costly, especially when you're dealing with these sensitive materials and strict timelines. So, yeah, predictive maintenance is a real game changer.
Okay, so we have a cutting-edge pump, intelligent software, a crystal ball for maintenance. What's next? A self-cleaning pump.
Haha, maybe someday. But in all seriousness, they're not stopping there. They're also actively forming partnerships with system design companies and distributors, making sure that the Pixar can be easily integrated into both existing and future biopharma facilities.
Smart move.
Yeah.
Even the most groundbreaking technology needs the right support to really take off.
Exactly. It's about building that whole ecosystem, one that benefits everyone, from the scientists and engineers working with this every day to the patients who ultimately rely on these therapies.
Well said. We've covered a lot of ground in this deep dive. The Pixar's unique design, this incredible versatility, the polymorphic pump technology, and of course this whole ecosystem they're building around it. It's clear this technology has the potential to really shake up the biopharma industry.
I completely agree. The Pixar's gentle touch, its adaptability, and the company's vision for the future, it all points to a potential revolution in biopharmaceutical manufacturing.
And you know what's really exciting? This technology, this level of precision and gentleness, it could have applications beyond just biopharma. Think food science, cosmetics, maybe even handling sensitive nanomaterials. The possibilities are huge.
Absolutely. The Pixar is a great example of how innovation in one area can spark advancements in others.
Well said. And on that note, we've reached the end of our deep dive into the world of the Pixar pump. We hope you enjoyed this journey into the cutting edge of biopharmaceutical technology. And until next time, keep those brains engaged.